Hello. So last class we went over the power rule, the constant rule, and the sum and difference rule. So if you can see this here, slip. If you take the derivative of a constant, let's say c. So these are just different notations here. The derivative of just a number, like if that was f of x equals 3, the derivative of that is going to be 0. And if you can remember, the graph of a function with just a constant is just a horizontal line. So the slope of a horizontal line is 0, and that's why that happens here. So looking at this example, if you were given a function f of x equals 3, f prime of x equals 0, if your function was find dy over dx, and it gave you y equals 3, your value would be 0, okay? So don't be scared on these. This is just saying like f of x equals c, y equals c. It's just asking what is the derivative of c. And there you go, that's the answer. Okay, now we're off to the power rule. So again, these are just different representations of a derivative. So what you're going to do, you're going to put the power here, and then you're going to subtract from 1 to find the derivative. So, example, so we have y equals x to the 6th. Put the 6 in front and then subtract from 1. You get 6x to the 5th. Constant multiple rule, so if you have a constant and then a function, such as, I don't know, 3x squared, which we're going to see, it's going to be the constant times the derivative. Okay? So we have here, so we have c equals 3, fx equals x squared, f prime of x would be 2, subtract 1 from there. So you're just going to do 3 times 2x, which is 6x. Sum and difference rule, it's pretty much just like limits. You just add them all together. So here's power rule. So you're going to do 4 times 3 is 12, subtract 1. You get x equals 3. And then 3 times 2 is 6, subtract 1, and you get 2. Okay, now we're going to do the product rule. So the product rule is when you have two functions, I'm going to use f and g. Okay, so say you have f times g. Y equals f times g. The derivative of that is going to be y prime equals f prime of g plus g prime of f. So you're just alternating derivatives. Okay? And an example of this would be if you had y equals three x squared plus 2. I'm going to put it over here so we have room. So y equals 3x squared plus 2 times 5x cubed minus 2x plus 3. So yes, you can multiply and then do the power rule, but we're just going to use the power rule, but we're going to do the product rule. So f is going to be the first function you see. So you have f equals 3x squared plus 2. F prime is going to be 2 times 3, which is 6, and then subtract 1. And then derivative of a constant is 0, so you have 6x plus 0. G is going to be 5x cubed minus 2x plus 3. Do the power rule. 3 times 5 is 15, and then subtract 1 from the exponent. This exponent here is 1, so you're going to do 1 times 2 is 2. 1 minus 1 is 0. X to the 0 is 1. And then the derivative of a constant is 0. So now we're going to do the power rule. So it's going to be f prime of g. So it's going to be 6x times g, 5x cubed minus 2x plus 3 plus g prime times f. 15x squared minus 2 times 3x squared plus 2. Okay, so there's the product rule. If you want to continue simplifying, you can. So you're going to have 30x to the 4th minus 12x squared plus 18x plus 15 times 3 is 45, x to the fourth. Outside 15 times 2 is 30. Minus 6x squared minus 4. Combine like terms. 30 plus 45 is 75. Negative 12x squared plus 30 is 30 minus 12, so that is 18. Then your x's, oh, there's another one right there, minus 6x squared. So 18 minus 6 is 12. Okay, and then 18x minus 4. Okay, so that's that simplified. So that's the product rule. Now we're going to do the quotient rule. So this is if you have a function over a function. So you have y equals f over g. Y prime is going to be, just like the product rule starts, it's going to be f prime first, f prime g minus g prime f, okay, all over g squared. Okay, so the only difference, so you have something over g squared and then you're subtracting, but same order as the product rule. Okay, an example for this one, we have y equals x squared plus 5x minus 1 over x squared. F is x squared plus 5x minus 1. F prime is 2x. G is x squared. G prime is 2x. Oh, plus 5. Okay. Product rule, y prime. Again, another way of saying this, if your book says find dy over dx, that's just saying it wants to find the derivative of this. Okay, so this would be dy over dx will equal the derivative. Y prime is the same thing as saying this. Okay, it's the same thing. So f prime is f prime of g. So I make it a, well, whatever, 2x plus 5 times x squared. If you want to put the x squared on that side first, that's fine. Minus g prime 2x times x squared plus 5x minus 1 over x squared squared. Simplify, you get 2x cubed plus 5x squared minus 2x cubed minus 10x squared plus 2x over x to the fourth, which gives you 2x cubed minus 2x cubed cancels out. 5x squared minus 5x squared is negative 5x squared plus 2x. Okay. Factor out the x, this x to the fourth. Okay. And your answer is all simplified out is going to be negative 5x squared plus 2 over x cubed. So quotient rule deals with a lot of factoring. You could have also factored right here. Okay. Okay, let's do more examples on finding derivatives. Okay. So now we're just going to do a bunch of examples so you can see all along. So examples. Okay. One is going to be x cubed over 3. So x cubed over 3 minus x. Now remember, another way to write this is 1/3 x cubed. So when I multiply by 3, the 3 goes away because I'm going to have 3, y equals, let's make it a y equals. So y prime is going to be 3x squared over 3 minus 1, which is x squared minus 1. That's the derivative. Okay, next we have y equals x squared plus 1, x cubed plus 1. You could do the product rule, or you could FOIL and then do the power rule. It's up to you on how you want to approach that. I'm going to do the product rule just so you have practice. So F is x squared plus 1, f prime is 2x, g is x cubed plus 1, g prime is 3x squared. So your product rule is going to be 2x x cubed plus 1 plus 3x squared times x squared plus 1. So remember, it was f prime g plus g prime f. FOIL, or distribute, and then combine like terms. 2x to the 4th plus 2x plus 3x to the 4th plus 3x squared. Standard form is going to give you 5x to the 4th plus 3x squared plus 2x. And there you go. Okay, next one. So we're going to be finding the horizontal tangent for this one. So 3, find horizontal tangent of the function of f. Okay, now if you remember from earlier examples when we had to do the definition of a derivative, which is the limit as h approaches 0 of f of x plus h minus f of x over h, we had to set that equal to 0. Well, we're going to do the same thing here. To find the horizontal tangent, you're going to set y prime to not equal 0, and then you're going to solve. Okay? So we have y equals x cubed minus 4x squared plus x plus 2. So y prime is going to equal 0 because you're looking for a horizontal tangent. Why is it 0? Because if I was doing something like this and I wanted to see my tangent line at that point, it's going to eventually be 0. So that's where your horizontal tangent is, right here. So that's why you set the derivative to equal 0. So you're going to have 3x squared minus 8x plus 1. Are there factors of 3 that add to get negative 8? There is not. So we are going to have to do the quadratic formula. So x equals negative b plus or minus the square root of 4ac, or b squared minus 4ac, which is going to be 8 plus or minus 64 minus 12, which is 52. Okay, 52 is 4 and 12. Or no, 52 is 4 and 13. So that's going to be 8 plus or minus 2 root 13. which is going to be 3 4 plus or minus square root of 13 over 3. So that is where your horizontal tangents are at that x value. Okay. And that would be, if you were looking at a graph, that would be where the x-intercepts are on the y prime. Okay, now let's go to the next example. Let's do a negative exponent. So we have 4 let's do x to the negative 8th. Okay, so same thing as the power rule. Y is going to equal negative 8, x to the negative 8 minus 1. So y prime is going to be negative 8, x to the negative 9th. And now let's do, so I'm going to do find dy over dx of square root of x. Okay, so I'm just going to say y equals square root of x, rational exponent, go ahead and turn into that, x to the 1/2. Y prime is going to be 1/2 x to the 1/2 minus 1. Common denominator, 2 and 2. Be very familiar with this one. It's going to happen a lot in this course. 1/2 x to the negative 1/2, which is going to be 1 over 2 x to the 1/2. So you don't have a negative exponent. You just put it on the bottom. And so you're going to have 1 over 2 square root of x is your derivative. Your book may stop here, but I say if you can go here, you can stop there. Okay. Higher order derivatives. So higher order just keeps on going as it is. So if we have, so we'll do higher order derivatives. You just keep taking the derivative until you can't go no more. So the second derivative, if we're using like f as our original function, the second derivative is going to look like f double prime. The third derivative is going to look like f triple prime. The fourth derivative is when you can just do f of 4 and so on. Okay, so we are going to find the first 4 derivatives of this next problem. So we're going to find the first 4 derivatives, if we can, of y equals x squared plus x plus 3. So same thing with, you saw f primes, y works the same. First derivative is 2x plus 1. The second derivative is 2. The third derivative is 0. The fourth derivative is not applicable. You can't go past 0. Okay. Now, one more problem, and then we will be done. Suppose u and v are functions of x and are differentiable differentiable means it just has a derivative at x equals 2. And u of 2 equals 3. u prime of 2 equals negative 4, v of 2 equals 1, v prime of 2 equals 2, so 1. You're going to find the derivative, the values of the derivative of u and v. So this is the product rule. Okay, so it's just u prime v plus v prime u. Your book may have it backwards. I just do it this way. It doesn't matter because adding is commutative. It's just easier with the quotient rule to get everything aligned. So now you're going to do u prime of 2. So u prime of 2 is negative 4. V is 1, just looking at the y values, plus v prime is 2, and u is 3. So you get negative 4 plus 6, which is 2. Okay, one more. So you're looking for the derivative at 2, and you're using this information. Okay, u prime of 2 is negative 4, v prime of 2 is 1, v prime of 2 is 2, u of 2 is 3. So now we have d over dx of u over v. So this is the quotient rule, which is u prime v minus v prime u over v squared. So you're looking for that of 2. So u prime is negative 4, v is 1, v prime is 2, u is 3 over v squared, which is going to be 1 squared. So you're going to have negative 4 minus 6 over 1, which is negative 10. Okay? And your homework is going to be page 124, 1 to 37, odd, and 41. Okay? This concludes this lesson. Have a great weekend.